Hi, I believe you have seen my Tesla coil that has beautiful arcs and plays nice music. Yes, it works, but it's not the best circuit. It might come as a surprise to you, but my designs are not necessarily safe or efficient. I designed them for a video to make a point quickly. There hasn't been any complaints, probably because there were no survivors. Just that I can see a lot of you trying to make this circuit, so I should explain a few things. Let me plug it in so I can show you a few things. I forgot, this was the first problem with the circuit. Although I wanted to rectify the AC line and make it work on a high DC voltage using my full bridge rectifier, it would blow up at that voltage, so it only works on 30 volt DC. And that's not the only problem with it. It is very hard to tune it to resonance frequency, and it's not an efficient circuit at all. Well, that's pretty much it. I mean, the damn thing plays music out of its arcs. What else do you expect? But let me explain. See, a Tesla coil works by tuning the primary frequency exactly to the resonance frequency of the secondary, which is made by the secondary inductance and the capacitance of the top load to the environment. Here I'm driving my Tesla coil by my low power Slayer exciter circuit. The benefit of such circuit is that it oscillates based on a feedback from the secondary, so it automatically tunes to the resonance frequency. Let me measure the frequency for you. I probably shouldn't do this. But I have some information about Keysight I'd like to leak. Whatever, I'm not their employee, so they can't fire me. Let's do a proper leakage setup. You know Keysight, right? They make the toppest quality oscilloscopes. Now I have this snitch that gives me information here and there, and he told me that Keysight is coming up with this very affordable but very good line of oscilloscopes, 1000X series. The Keysight is in anticipation of this big announcement 1st of March, but I guess I'll ruin the surprise for everyone.
What are you doing in there?
I'm leaking here!
That's not the washroom!
Oh. And every year March is their oscilloscope giveaway month. This March they are giving away over 125 scopes. It's like 5 scopes a day. I mean, this is the best chance for you to get the tool you need for free. All you need to do is to enter some website, scopemonth.com. So if you need this tool and you're not a total idiot, you better sign up. I'll sign up too, although Snitch found and sent me one of those 1000X series oscilloscopes. Let's see what it is about. Oh, that's cheap. What is it, a toy? Hey, I'm your probing pal. Let's probe together. Yippee! Oh no, that's not very probe. Yippee! Oh, that's... Wow, okay. Look, this is an 1102G 100 MHz 2-channel scope with mega zoom, 20 MHz function generator, dedicated digital voltmeter and frequency counter, and frequency response analysis. This will crush the competition. I should get a few of these for my patrons at the end of the video. Let's get back to my Tesla coil. Now I'm measuring the frequency of my circuit that's oscillating at the resonance frequency of my coil. You can see that it's around 1 MHz, but as I bring my hand close, the frequency drops to 800, 700 kHz, and it's because the capacitance of the top load to the environment is increasing. This shows that the resonance frequency is very dependent on the environment. And that is precisely the problem of my musical Tesla coil circuit. It doesn't have any feedback from secondary and only works at a fixed frequency I have to tune. So as soon as I move around my coil, the resonance frequency changes and it stops working. Now to discuss the next problem, let me shove this capacitor into the power line. Now you might say this was a pretty dangerous and pointless thing to do. You're probably right. No, wait a second, I'm pretty sure I had a good point. Oh yeah, unlike a capacitor that shorts AC, an inductor shorts DC, and a transformer like Tesla coil only passes AC to the secondary. So having a DC or direct current component on the primary of a transformer just shorts it and wastes a lot of power. But my circuit that only switches the primary on and off to ground results in a pulse train of current that's only positive. This has large AC and DC components, with DC being useless and a large waste of power. This is why my transistors heat up and can blow up at higher voltage. But then you might ask, Mr. Sadaghdar, with all your smarts and genius, why did you design such a circuit? Elementary, Watson. This was a quick and dirty way to make the Tesla coil sing, and after spending 3 months on a 5-minute video, I was done. So there.
Giveaway time!
Hey, Snitch. Oh, hi, can I talk to Snitch, please? How many? 25 snitches. Just yell unibrow in there, one of them knows me. 5 snitches with unibrow. No, I'm the guy with the unibrow. Your guy gave me a Keysight scope. Yeah, Yeah, I assumed his gender based on his voice. Sorry. Snitch, for future reference, are you a man or a woman? Free agent, what's a free... It doesn't matter, what's your last name? Snitchkov, you're Russian. Nigerian prince. No, I don't want your $1 million. Listen, man, free agent, I need more of those Keysight scopes for my patrons. Do you have more? 3 more. Yeah, send it over. Great. Also, don't forget to enter Keysight's huge scope giveaway at scopemonth.com. Also, if you want great information on oscilloscopes, Keysight Oscilloscopes channel, go watch it.